Moving on to question 8 on page 2. If Sabrina wants to improve the solubility of a solute, that means when you improve the solubility, you make it more soluble. That means you make it dissolve better. Okay? So she could do the following. If I increased the size of the solute, that means if I made the size of the solute more chunky, would it dissolve better? No. If I heated up the solvent, if I made this warmer, would that help me? Yes, that would help you heat up, dissolve the solvent better if we heated it up. Dissolve the solute, sorry. If I increase the amount of solvent, yes. If I put a little bit more solvent in it, that would be a good way to do it. And then the last one is make more solution. Well, if I make more, that doesn't make it dissolve easier. So we have two parts that are pretty close. But what we want is the best answer. And the best answer is to heat it up. Because remember, there's 3 things that help solubility. You stir it, you heat it, and you crush it. Okay? So those 3 things help solubility. So heat it is the correct answer. Okay, number 9, Kihan wants to distinguish between 2 solid cubes. Okay, so he has 2 cubes. 1 cube is made of iron and 1 cube is made out of wood. He made a prediction that the mass of each cube would be the same because the cubes are the same size. Well, we know from our demonstration in class, we have 2 cubes that are the same size. They take up the same amount of space, so they have the same volume. But if 1 cube is made out of iron and 1 cube is made out of wood, the iron cube is going to be heavier or have more mass. Okay? So the wood cube would be much lighter. So let's take a look. So he says that the cubes would have the same mass because they're the same size. And we know that that's not correct. Now, let's take a look. So we know it's incorrect. But why is it incorrect? Is it incorrect because the matter in the iron cube weighs more? Don't forget, weigh is a bad word when you're talking about matter. When you talk about matter, you talk about mass. Remember, matter equals mass. And that's our little goat, meh, or our lamb, our sheep. So it's incorrect. One would have more mass than the other because the matter in the iron cube has more mass. Okay. Ivan wants to change the state of his matter. In order to change the state of his matter, you must. And don't forget, that's when we go from a solid to a liquid to a gas, or from a gas to a liquid to a solid. So we're changing state. That's a state, because a state is a solid or a liquid or a gas. There's 3 states of matter. So if we want to change the state, we need to change the temperature. And that's just a must-know answer. Okay, number 11. Sophia wants to use the most efficient method, and efficient means best, of separating 2 parts of a mixture of rocks and paper clips. Okay, so we have some paper clips in our mixture and some rocks. What is the most efficient way to separate the components of her mixture? Well, if you look at the choices, we have a magnet. That would be good because a magnet would pick up the paper clips. A sieve, well, we could use a sieve, but you would have to find a very specialized sieve that would hold the paper clip, so that probably wouldn't do. A funnel, well, you don't know if all of the rocks are the same size. And use her hands, yeah, she could use her hands. So, but we want to know what the best way or most efficient way is. And in that case, her hands is not, it's a magnet. A magnet will quickly pick up the paper clips and separate them from the rocks. Number 12, Simon wants to demonstrate a physical and a chemical change. So we want a physical and a chemical. How can he demonstrate both a physical and a chemical change? And what you need to do is put a P by the one that you know is physical and a C by the one that you know is chemical. Okay, so let's take a look. When you're making popsicles, that's a physical change because you're freezing liquid. And anything where you change the state, that's a physical change. Boiling water, that's a physical change as well. Bending a paper clip, well, it's still a paper clip even if you bend it, so that's a physical change. And freezing a turkey, once again, you're just changing it from solid to a solid, actually. You're just making it colder, so that's a physical change. Bending a metal rod, well, that's the same as bending a paper clip. That's a physical change. Burning a stick, that's a chemical change because when you burn something, you change it from one type of matter to another. And lighting fireworks, that's a chemical change, and digesting a hamburger is a chemical change. And don't forget, we want a P for physical and a C for chemical, which is C, physical, chemical. Okay? You can eliminate the other ones.